So this video follows on from basic friction, but it's going to mix in then inclined planes, which you've seen earlier in the course. So this example here, a book of mass 0.5 kilograms is placed on a rough slope. Very important. This shown as a rough, which means that friction is going to be involved, and it's inclined at 30 degrees to the horizontal. If the book is just on the point of moving down the slope, so again, very important, it's on the point of moving down the slope. That means it's in equilibrium at the minute, but we can use the maximum value of friction, limiting friction, because it's just about to move, and we're asked to calculate the coefficient of friction. So let's, first of all, as always, let's draw a wee diagram. So here's our slope. We know that it's at 30 degrees, and we have our book on there, and that's 0.5 kilograms. So the weight of that is going to be 0.5 G. I know that there's going to be a normal reaction, and I also know that there's friction involved. Now, we're told that it's on the point of moving down the slope, which means if it's going to be moving this way, then friction must be acting the other way. And because it's it's on the point of moving, we can use the maximum value of friction. And so I'm just going to put mu r there, the maximum value of friction. You could say Fr for frictional force, but let's say mu r because I know it's the maximum value. Anything else we know here? Well, this little angle to the perpendicular is the same as the angle of the slope, so it's 30 degrees, and we're good to go. So what do we do? Well, let's first of all let's resolve perpendicular to the slope, or right angles to the slope. And we can see here we have r going directly out of the slope, and the only other force that's going into the slope is this weight here, so we have to resolve it. And so when we do that, we're going to get r equals, well, it's 0.5 g cos 30. We go through the angle of 30 degrees here, so we go through this angle, so it's cosine 30. And we could work out if we want, but I'm just going to leave it for the moment, because then we want to look at parallel to the slope. So we've looked perpendicular to the slope, we're now going to look parallel to the slope. And what forces have we? Well, we have friction acting up the slope. The only other force that will have a component down the slope is again the weight. Don't forget to resolve it down the slope. And to resolve down the slope, we need to go away from 30 degrees, so it's going to be sine of 30 that we're going to use here. So we're going to get that mu r is equal to 0.5 g sine 30. And if we fill in from the first equation into the second equation, we're going to get mu times 0.5 g cos 30, sorry, equals 0.5 g sine 30. That's just filling in for r. And you can see then that both sides here we have 0.5, we have g, 0.5 we have g, and so we can quite quickly see that mu is equal to sine of 30 divided by the cosine of 30. Let me just put that into our calculators and get mu to be 0.577. So again, just make sure you have a diagram showing all the forces on it. And then instead of looking horizontally and vertically, if it's on horizontal ground, when we have a slope, we resolve perpendicular to the slope to work out any normal reactions, and then we look parallel to the slope. And either the force up will equal the force down if it's not moving, or if it's moving at constant velocity, or if it's moving with an acceleration, then we would use F equals ma, parallel to the slope. So let's look at this second. It's an exam question. I said, here's a car of mass 13 kilograms ascending a hill at an angle of 20 degrees. The coefficient of friction between the car and the hill is 0.25. So this tells us then that we are dealing with a rough slope. Doesn't say it in the question, but just the fact that they've mentioned coefficient of friction. The tractive force produced by the engine is 12,000 newtons. Draw a diagram showing all the forces. Now, even if it hadn't asked me to do that, I would have wanted to do that anyway. So Always good to draw a good diagram. There's 20 degrees. We've got our car, and the mass of that car is acting straight down. Now in this case, we know that the car is 1300 kilograms, so the mass times gravity, 1300 g. We have a normal reaction from the car. And we're told that the attractive force of the engine of the car is 12,000 newtons. That means there's a force going up the slope of 12,000 newtons. Now, we're also told then that the coefficient of friction is 0.25, and we're asked to find the acceleration of the car. Now, if it's accelerating, it's going to be accelerating up the slope. Which means that if it's going up the slope, friction must be acting down the slope. And that's the maximum value of friction there, so we're going to call it mu r. Or we could put 0.25 r if we wanted. So that's it, the diagram showing all the forces that are on this. Again, if you want, you can maybe just put this wee angle in if it helps. But there are no other forces acting on this. So let's resolve perpendicular to the slope. So again, what force is perpendicular have? Well, obviously the normal reaction. The only other force in and out of the slope is this one here, but we're going to have to resolve it. These two forces are parallel to the slope, so they're at right angles to this. They won't have any effect on the perpendicular resolving that we're going to do here. So here then we get that R is equal to 1300 G, but we need to resolve that. We go through the angle of 20 degrees, so it's 1300 G cos 20. And again, if you want, you can work that out in your calculator, something like that, 68 newtons. Again, I've done that to 7 significant figures. Much better to be more accurate at this stage than not. We'll round our final answer to 3 significant figures, but not yet. So we've resolved perpendicular, then we're going to look parallel to the slope. And this time we do have an acceleration. We're asked to find it here, and we've put it into our diagram for this. So let's start with using Newton's second law, F equals ma. Let's fill in what we know. What's the overall force up the slope? Well, up I have this 12,000 newtons. Down the slope, acting away from that, I have friction. And here's the one that people forget about, but you must always remember to resolve the weight down the slope. The weight of the car will always be acting down the slope. So let's put those 3 in. Up the slope, 12,000 newtons. Down the slope, so it's minus mu r. So mu is 0.25 times r, which is 11971.68. And we also have minus the 1300 G sine 20. Those are our 3 forces, and that will equal to the mass times the acceleration. And the mass is 1300 kilograms, and the acceleration is what we want to find. So we're just going to call that A. And when we put that all into our calculators, we get that 4649.76 is 1300A, and so we find the acceleration is 3.58. And at this stage, I'm doing it to 3 significant figures, and meters per second squared. Final example here, and this time just we've got a slope, but we also have a force as an angle. So let's draw a diagram. A mass is pushed up a rough slope at 45 degrees to the horizontal. So here's our rough slope at 45 degrees. We've got our mass being pushed up it, and it's 10 kilograms. So let's write 10 G for the force and the normal reaction. And again, to the perpendicular, this angle is going to be the same as the angle of our slope. So, what's next? The acceleration of the mass is 2 meters per second squared. So we can put that in 2 meters per second squared. And the coefficient of friction is 0.7. Calculate the value of the applied force if the force is applied horizontally. Well, if it's going up the slope, our friction will be acting down the slope. So I'm just going to write mu r here. And the last thing is then that we have a horizontal force. I'm just going to call it x. But what I do know is that if you remember your z-shaped angles, this line and this line are parallel. So these angles here are alternate angles, z-shaped angles. So if this is 45 degrees, this angle in here is also going to be 45 degrees. And we're going to use that later on. Okay. Now, apart from that, let's do what we've done before. Let's resolve perpendicular to slope. We just need to be a little bit careful here, because acting out of the slope, we have a normal reaction, but actually we have two forces that are acting into the slope. And so we're going to get that R is equal to, well, we've seen the 10g cos 45, that's the easy one. But we've also got this force X that's acting into the slope. And if I want to resolve it so that it's acting this way, I'm going to have to move it away from the 45 degrees there. So that's going to be X sine 45. And we just leave that for the minute. We can't do much to that just for the moment. So what do we do next? We look parallel to the slope. Now there is an acceleration here, so we're going to use Newton's second law, F equals ma. And the overall force is going up the slope. And actually, again, X is the only force that's going to have a component that's going up the slope. But I'd need to resolve it round here so that it's pointing this way. And so that becomes X, sorry, not sine, cosine 45 degrees. However, we have two forces that are acting down the slope as well. We have mu r, so I'm going to take minus mu r, and we also have the weight of the object. Don't forget about the weight. So it's minus 10g sine 45. And that's going to equal to the mass times the acceleration. So 2 times 10 is 20. So let's fill in a wee bit more here. So we've got x cos 45 minus, well, friction is 0.7, and r we've got as 10g cos 45 plus x sine 45. And then we have minus our 10g sine 45 equals 20. Now I know that cos 45 and sine 45 are the same, so all these terms have sine 45 in it, and I can take that out just as a factor. So cos 45 or sine 45 leaves me x minus, well, 0.7 times 10g is just 7g, minus 0.7 times x is just minus 0.7x, and then minus 10g here. That equals 20. So x minus 0.7x is 0.3x, minus 7g minus 10g is minus 17g, and that equals 20 divided by cos 45. And so when I take everything to one side, 0.3x, we end up getting as 194.88. And so you find then that x is equal to 649.614. If I'm doing that to three significant figures, 650 newtons. And so we've managed to use our mixture of friction, mu r, and resolving forces on an inclined plane, looking perpendicular to the plane and also parallel to it, to solve whatever we're looking for here.